Hello, my name is Dustin Coy, and I would like to welcome you to the final presentation of Team 3's Band-in-a-Box design. Team 3 members include myself, Michael Payton, and Philip Knisley. Throughout this process, our top design goal was to build instruments that have a high level of playability and can accurately reproduce all the desired frequencies for our customer Maroon and Gold, and as well as meet the requirements that they would all fit in a 2 foot by 2 foot by 2 foot traveling box, cost less than $15 each, and also stay under a restriction of using no more than 6 feet of string and 10 feet of pipe. We also wanted to create a recording of Ode to Joy using our instruments to demonstrate that the final instruments are capable of producing the desired notes. So for this project, we designed and built 3 instruments, 1 string, 1 wind, and 1 percussion instrument that would allow us to produce each of the voicings of Ode to Joy. The Devil's Fork is our stringed instrument, and it will have a familiar feel for guitar players. Currently it is tuned to an open D4 for the high voice output needed for Ode to Joy, but you can easily change the frequency by output by adjusting the tension on the string or by fretting the string similar to a guitar to allow for multiple different frequency outputs. The pan flute is our wind instrument, which by design is a compact, lightweight instrument that covers the entire mid-range of frequencies necessary to play Ode to Joy, but it is also adjustable by adding extension pieces that are included to create the necessary frequency outputs. The hanging bars are our low-end percussion instrument that has adjustable tone quality and frequency response by substituting different bar material types, and its current right angle design enables musicians to play quicker tempos with better frequency response than our original proposed design. So now that we've talked about our goals and a little bit about each of the instruments, here's a bit of a closer look at the Devil's Fork, our stringed instrument. The final cost of the instrument and some of the design challenges faced along the way will be covered a bit later in the video. For future improvements, though, I would like to add a pickup and a speaker inside of the resonator can to give it an electrified sound. Okay, so now I'm going to go ahead and turn it over to Michael Payton, and he'll take us through the underlying physics of our designs, as well as some of the challenges that we faced along the way. Michael?
Thank you, Dustin. So, how did we go about engineering our instruments? Well, to get to the heart of it, we had to find a way to produce the fundamental frequencies that are associated with the notes, and we wanted the instruments to be able to play. The Devil's Fork was our solution for the high voice instrument. This instrument needed to be capable of producing 6 frequencies. We had to choose a string with appropriate linear mass to produce the desired frequencies under tension without breaking. Dustin was able to come up with a solution using 1 string and several strategically positioned frets. So this was our original design. Dustin ran into a few challenges while implementing this design. The first challenge was determining what the linear mass was for a given string. All the strings he could get his hands on didn't come with details about what the linear mass was. And also, he had to determine the appropriate tension to apply once he knew the linear mass. Ultimately, Dustin utilized the guitar string and was able to achieve the appropriate tension by adding an extra 1/4-inch staple to keep the string secure. The middle voice pan flute that Phil designed had to be able to play 14 different frequencies. Phil had to choose the correct diameter of pipe and the appropriate length of pipe, and he was able to do it while coming under the 10-foot limitation that was applied. His design had some minor challenges also. First of all, the original design only accounted for 9 of the 14 frequencies. Phil's solution to this problem was to add additional PVC to the end of his existing pipes with couplers that would allow a single pipe to play multiple frequencies. The hanging bars was our low voice percussion instrument. And creating this instrument, we had to produce 9 different frequencies. Here you see my original design. This design probably underwent the greatest number of changes. It was difficult for a musician to strike the different bars, and also it was difficult for the bar to be struck evenly and solidly with a drumstick that did not produce high frequency interference, this being a low voice instrument that wasn't ideal. The solution was to alternate the bars on different faces of the handle and manufacture my own drumstick out of a wooden dowel and some hot glue. I'm going to pass this over to Phil now, and he's going to let you know a little bit about our costs, what we learned, and provide a demonstration of Ode to Joy.
Okay, thanks, Michael. Now we're going to go over the costs of the instruments. I'm happy to say that all of our instruments came in way under budget. We only spent about half of the money that we were allotted for this project. I'll go over each one individually here. First of all, the hanging bars that Michael made, they came in at $5.20, quite a bit under the limit of $15 there. And the pan flute that I made came in at $5.68, again, quite a bit under the limit. And the Devil's Fork that Dustin made came in at $11.17, by far the most intricate design of the three that we had, and also still under the limit. Okay, and these are some of the things we've learned throughout this process while working on this project. First of all, we've all learned about the physics of acoustics and how to build our instruments and make all the calculations. And most importantly, I think what we've learned about, and the reason why we're all in this, is to learn about the engineering process. And I think some of the most important parts of the engineering process that we encountered were going from just having an idea to constructing a prototype, testing and evaluating it, and then finding ways that we can improve on it and get to the point where we've solved the problem and we've came up with a solution. And finally, the teamwork has been a real good experience, especially on this online environment where we've learned to coordinate and communicate effectively in order to complete all of the objectives for this project. Okay, now we're going to play a real quick demonstration of the hanging bars and the pan flute. You already heard the demonstration in the introduction of the Devil's Fork. Thank you.